Hi everyone. This is the second half of this topic, which is multiply and divide rational expressions advanced. I did the first two. I did problems 1 and 2 in the previous video, and I'll do problems 3 and 4 here now. Okay, so let's begin. Now again, let's remember our steps. If it's a division, keep, change, flip, right? If it's a division, only if it's a division, and then of course factor, cancel, and then multiply across. Okay, now here I just want to reiterate that this step on factoring, we should always look for a GCF first, right? Always look for a GCF first before you start, breaking it up into binomials and whatnot. So always look for a GCF first. Okay? Now, let's go to the problem. This is definitely a division, right? That's a division. So we're going to have to apply KCF. So let's do that. We have x squared plus 16xz. There's going to be a lot of variables in here, right? Plus 64z squared. Okay? Okay, guys, so let's continue. And this is going to be over x squared times z plus 8x z squared. Now this is times, and then let's flip this, so we have x to the 4th z minus 9x squared z cubed all over x squared plus 5xz minus 24z squared. Okay, so a lot of variables in here, right guys? Okay, let's try to make some sense out of this. So we did the keep, change, flip, and now let's go to the factoring. And again, when we're factoring, we always look for a GCF first, and then we factor, okay? We factor maybe into binomials and whatnot. So let's take this first one right here. Okay, so this first one, I think, okay, if you look at it closely, if you were to just not look at the z's and just rewrite this without the z's, you would see that's x squared plus 16x plus 64, right? And that is a perfect square trinomial, correct? Well, the only difference is that this thing has a z in the middle term and z squared on the end. It's still going to be a perfect square trinomial, but the binomials now will contain z's, right? So again, this thing, if it didn't have the z's, would look like this. So x, sorry, there should be a parentheses, x plus 8 times x plus 8. If there were no z's, right? But since now it does have z's, there's a z squared here and there's a z in the middle term, all you have to do is just include a couple of z's, like that. Okay, and if you were to FOIL this, you would get this trinomial back. Okay, all over. Now let's, again, when you're factoring, always look for a GCF first, right? So it looks like in here we have a couple of GCFs, right? We have an x, and we also have a z. So if you were to factor out an x and a z, you'd be left with x plus 8z, like that. Okay? Times. Now let's factor the top again. Always look for a GCF. And again here, it looks like we have an x squared, and we also have a z. And that's going to leave us with, x squared minus 9z squared, right? This is going to be x squared minus 9z squared. And I wrote it up top here because I just wanted you to see that this is also a difference of two perfect squares, correct? So if it didn't have z squared, it would look like this, right? X plus 3 and x minus 3, right? Without that z squared. But since it has a z squared now on the back term, all we have to do again is just include a couple of z's. All right? And then finally, this bottom one. Again, if you didn't have the z's, it would be x squared plus 5x minus 24, which then would factor into, this would be x squared plus 5x minus 24, right? And that would have factored into, let me see, that's 8 and 3, right? So it would be 8x plus 8 and x minus 3. Again, however, it has z's in here, right? It has a z in the middle term and it has a z squared in the last term. So again, all you have to do is add a couple of z's. And now everything is factored. Okay? Now it's time, everything is now factored, so it's time now to cancel. All right, let's cancel. So let's start off with the left terms. We have x plus 8z, x plus 8z, correct? We have another x plus 8z with another x plus 8z. We've got a couple of x minus 3z's here. And it looks like I could get rid of these z's here. Get rid of the x down here, and get rid of the squared here, which leaves me with that term, with that x. Okay, so final answer. It looks like we're going to have x times x plus 3z. Okay, and the denominator I don't think has anything, right? Every term in the denominator canceled out. So let's write that in. We have x times x plus 3z. Okay, and again, you could write it in factored form, or you could write it in expanded form, right? If you wanted to expand this, you could have written this as x squared plus 3xz, but I don't really think there's a need unless the directions told you to write this in expanded form, right? This is expanded form, and this is in factored form, correct? Oops, sorry, factored. Okay, so let's check. And that is correct. All right, and finally, let's go to the fourth problem. All right, and this is again, this is a multiplication. So there's no need for keep, change, flip, right? Just factor, cancel, and multiply across. Okay, so let's do it. Right, so first, let's factor. Looks like we're going to have, this is x to the 8th, correct? That's x to the 8th. Now again, we draw the parallel, okay, to, if that was x squared and that was, I'm sorry, if that was z squared and that was z, then of course this thing would have factored into, z times z, and here the 30, well that's 30 is 6 and 5, so it would have been plus 6 and plus 5, right? But it's not z squared, it's z to the 8th. So therefore it looks like we're going to have to do z to the 4th for each of these, right? Z to the 4th. It's because z to the 4th times z to the 4th is z to the 8th, right? Okay. Divided by, this is 18z squared plus 12z plus 2. Now again, this thing we can do using borrow and payback, right? So maybe, you know what, let's factor everything else first, and then I'm going to show you borrow and payback here. I'm not going to use guess and check. I've already shown you guess and check. So we'll do this one using borrow and payback, all right, and see how that works. All right, but let's factor everything else first. Times. Again, always, right, always look for GCF. There is a GCF up here. So it looks like it's going to be 8z. If I factor that out, it's going to leave me with 3z plus 1. Okay, over, and again GCF, take out a z, leaves me with z plus 6. Okay, guys? Now, let's do this using borrow and payback. So here's our borrow and payback. Here we have 18z squared plus 12z plus 2. Okay, remember borrow and payback? Multiply the first coefficient with the constant and get rid of the first one, right? Put a 1 there. So z squared plus 12z plus 36. Okay, and now let's factor this one. Now it's easy to factor because there's no leading coefficient. So it's z, okay, 36. Well, that's 6 and 6, right? But also they add up to 12. So plus 6, like that. Okay, and now we borrow the leading coefficient. So let's borrow the leading coefficient. So we have 18z plus 6 times 18z plus 6. And then we factor each one separately. So we can take out a 6 here. That gives us 3z plus 1. And then we can take out, let me see here, we can take out another 6. And that's going to leave me with 3z plus 1. Okay, now the payback, so this is the borrow part right here, right? That's the borrow part. Now comes the payback time. Okay, we borrowed, let me highlight it, we borrowed these 18s here, correct? Which means we need to pay back 18. If we look here outside the binomials, we have 6 times 6. Well, 6 times 6 is 36. That's too much. We just need to pay back 18. So we can pay back the 6 here, and we can pay back a 3 here, right? Because 6 times 3 is 18. So if I broke this up into 3 times 2, 6 times 3 is 18 like that. So we're still going to have a 2 left. So it looks like this thing is going to factor into 2 times 3z. That's a plus, by the way, guys. Plus 1 times 3z plus 1. Okay? And this is the correct factorization of that whole big thing. So let's write that in. Okay, so we're going to have 2 times 3z plus 1 and 3z plus 1. Okay, and now it's time to cancel. So let's start canceling here. Let's use this one. All right, so factored. Now it's time to cancel. So we're going to have a 3z plus 1 with a 3z plus 1 here. The z's here cancel out. Okay, the 2 is going to cancel out with the 8, leaving me with 4. And I think that's about it. Okay, so let's type it in. Wow, it really didn't cancel that much, did it? So let's type it in and see if we're right. So we have z to the 4th plus 6 times z to the 4th plus 5 all over 3z plus 1 times z plus 6. Okay, and we are correct. Okay, Take care.